Okay, now our second objective is to simplify what are called roots. Okay, so roots are just things that look like this. Okay, the square root sign. So this means root. Or another word you might hear is radical. Okay, so when you see that sign, you're used to hearing this called a square root. Okay, when there's no number here, then it means a square root. But sometimes, like if you look at B down here, there's another number here. So this would be called the cube root. Alright, but there's no number, it's just called a square root. So this sign means root. You'll also hear it called radical. Okay, those mean the same thing. When you want to simplify a root, you have to think what number times itself, however many times the root tells me, okay, what number times itself gives me the number under the radical sign. So the radical sign is that sign that looks like this one right here. Okay? So part A, again, I'm thinking to myself on this one. Now there's no number here, so that means I'm taking something times itself just twice. Okay? So I want to know what times itself equals 144. Well, 12 times 12 is 144. So then the square root of 144 is just 12. Okay? So notice when I wrote my answer, this is important, when I wrote my answer here, I only used one of these 12s. Okay? I didn't use them both, so my answer is just 12. Again, because 12 times 12 equals 144. How did I know I only need to take it by itself twice? Because there's no number in here. So let's look at B. This asks for what's called the cube root of 27. So notice it's got this little 3 right here. That tells me I want to multiply something by itself 3 times to equal 27. Okay, sorry, I should put a B here, and C or A was over here. Okay, so I want to multiply something by itself 3 times. So what times itself 3 times gives me 27? Okay, now again, this is a little mental math here. So the best way, if you're not sure on this one, you can kind of guess and check, okay, with some low numbers. Well, think about it. If I put 1 in here, 1 times 1 times 1 is not 27. If I put 2 in here, 2 times 2 times 2, well, 2 times 2 is 4, 4 times 2 is 8, that's not 27. Okay, so what if we tried 3? 3 times 3 times 3, does that equal 27? Well, 3 times 3 is 9, and 9 times 3 is 27. Okay, so our answer, the cube root of 27, is 3, because 3 times itself 3 times gives me 27. Again, we had to know that we multiplied it 3 times because of this little number 3 right here. Okay, let's move on to more examples. Okay, example 6. The floor of a square room is covered with square foot floor tiles. If 100 tiles cover the floor, how long is each side of the room? So basically what they're telling us is in this little space right here, there's 100 little tiles. Okay, now the sides, you will notice this is square. So think about this. This is our area in here. Okay, remember that area of a square that we had? Area equals a side squared. Okay, well they're telling us what the area is because that's the space in here. We know the area is 100. And that's got to equal our side squared. So again, think about what squared means. That means what times itself, okay, or that means something times itself twice. So 100 equals something times itself. So I'm asking myself now, what times itself is 100? Okay, what times itself is 100? That answer is 10. Okay, so this S right here has to equal 10, because 10 times 10 gives me 100. Now, we need to make sure that we answer the question. It says, how long is each side of the room? Well, we're in feet, so it's 10 feet. So really all we did to solve this problem right here, again I want you to show this, but what we did is we took the square root of 100, meaning what times itself gives me 100, and that was 10. Okay, then we got two more examples. Okay, objective 3 is to define and find perfect squares. A perfect square is a number that has a whole number square root. What that means is that if I asked you what the square root of the number was, you would know what it is. Okay, so let's do some examples here. Okay, and let's show how we find perfect squares even. Alright, so let's use, because I think 4 is a good example. Okay, 4 is a perfect square number. The reason 4 is a perfect square number is because you know what the square root is. The square root of 4, meaning what times itself gives me 4, is 2. 2 times 2 is 4. Okay, so that is a perfect square. So, what we're going to do is we're going to make a chart. Okay, some perfect square numbers. Now, let me move this a little bit here. Okay. So we know that 2 times 2 equals 4. So that means that 4 is a perfect square number. Okay, so I'm going to put my perfect squares in a little box right here. Whoops. Okay, so our perfect squares are going to go in there. Well, how we're going to figure this out, what numbers are perfect squares, is we're going to take numbers and multiply them by themselves and see what we get. So, 1 times 1 gives me 1. That means 1 is a perfect square. Okay, we can go back. 0 times 0 gives me 0. So 0 is a perfect square. Now we'll start at 0 and we'll just go forward with bigger numbers. Okay. So now 3 times 3 gives me another perfect square. 9. So if I ask you for the square root of 9, you can tell me that's 3. That's a whole number answer. Okay, so that's good. That's a perfect square. 4 times 4 gives me 16. 5 times 5 gives me a perfect square number, 25. 6 times 6 gives me 36. 36 is a perfect square number. 7 times 7 is 49. So 49 is a perfect square. 8 times 8 is 64. 64 is a perfect square. Okay, 9 times 9 gives me 81. So 81 is a perfect square number. And 10 times 10 gives me 100. So 100 is a perfect square. Okay, let's keep this chart going here for a little bit. We could do 11 times 11 and get 121. Okay, so let me do this. Nope. So there we go. We'll get rid of that for now. Okay, so 11 times 11 is 121. So again, this is our perfect squares right here. In this column. 12 times 12 would give me another perfect square number. It's 144. So the square root of 144, we know that. That's 12, because 12 times 12 gives me 144. 13 times 13, another perfect square number, is 169. Okay, then after that we can do 14 times 14, and that gives us another perfect square number, which is 196. And we'll stop at 15 times 15, gives me another perfect square, 225. Okay, so the numbers in the red boxes are the perfect square numbers. Okay, so I've given you the first, let's see here, given you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. First 16 perfect square numbers. Okay? And again, the perfect squares are the ones in the red box. Those are the ones that we know the square roots of. Alright, let's go on to the last example. Okay, next example says to name the first three counting numbers that are perfect squares, then find their positive square roots. Okay, so I gave you that list. So the first three counting numbers, remember 0 is not a counting number. So the first three counting numbers that are perfect squares are 1, and then 4, and then 9. Okay, that's why I gave you the chart. So now, they're positive square roots. They want to know what's the square root of 1. Means what times itself gives me 1. That answer is 1. Okay, square root of 4. What times itself gives me 4. That answer is 2. And then for 9, the square root of 9. What times itself gives me 9. That answer is 3. Okay, if you have any questions, ask. Otherwise, happy homeworking.